So, the fact that this is a rhombus is important. When you have the diagonal in a rhombus, it cuts the angle exactly in half. I didn't do the best job drawing that in the picture, but this line, this diagonal, cuts the angle exactly in half. The other thing that you need to be able to see is where is angle ACB. So AC, yay, it's the top one. It goes from A up to C over to B. So it's that angle at C that goes to A and B. So this is 6x. And ACD goes down. It's the bottom one. So this is 4x minus 10. Can you guys in the back see? Yeah. Sorry. So because this diagonal cuts it in half, I can set these expressions equal to each other. Hey, we all had this make this 4x plus 10. It is one of our rules, Lily. You were exactly right. Solving for x, subtract 4x from both sides. Divide by 2.
It's out of focus.
I'll focus it. Give me a second. There. So all I did was I set them equal to each other and then just solved for x. And I got x equals 5.
It would be -5.
I asked you guys to change the minus 10 to a plus 10 for that reason. Because I wasn't thinking when I made the number up. So part 2 asks for the measure of angle BCD. That is the whole angle, the whole thing. So I'm going to do 6 times 5 plus 4 times 5 plus 10. Where did that come from? Samantha? I'm finding the whole thing, so we got to do both of these together. You could just find one and then double it. That's fine too. This is going to be 30 plus 20.
Ms. Levitt,
Yes, ma'am?
would you please send Bella Waters to check out in the front office, please?
Yeah.
Thank you.
So yes, it will be 60 degrees. Oops. So, next one is going to be a kite. What is the first one of these we know, x or y?
X.
Yes, and what is x equal to? Good job. So these angles are always equal in a kite, between the small and the big side. Now how do we find y?
We have the ones we have and we subtract from 60.
You got it. So we're going to take 360. I'm sorry guys, it's been doing a really bad job. Hasn't done this all day.
Minus 248.
Exactly. Yep. So take 360 and subtract, because this is 100, 248. Is that, what is it, 112?
Yes, ma'am.
I wanted to do one more with you guys. Oh. This is going to be a good one. Number 3 is going to be a rhombus. I want you guys to star this problem. You have not seen this before. I'm going to zoom out in hopes that it will stop getting blurry and just write bigger. Okay, so if you have a rhombus, and I'm going to do my best to draw this. It looks kind of like a kite, right? Yeah, or a square. But it's kind of, if you turn to the side, it's the tilted square. It's going to be a rhombus. I did my best to draw it, but I wanted it to be oriented this way instead of the normal way. So I'll even write. Let's write that it's a rhombus. And I'm going to tell you that this side length is 25. And if we name it A, B, C, D, the length of BD is equal to 40. And I want to know the area of this shape. So the nice thing about a rhombus, as well as a kite, is that if you draw the other diagonal, so I'm going to connect A and C. What is this angle here in the middle?
90.
Good. So I'm going to put that little 90 there. And now I have 4 right triangles. BD is 40. So in a rhombus, or in any parallelogram, actually, the 2 halves are going to be equal. The diagonals bisect each other. So if the whole thing is 40, what is from B just to the center?
20.
So we got 20. And I'll go ahead and jot 20 down there too as well. The area of a rhombus, if you forget the area of a rhombus, we're going to find the third side to the triangle, and you can do that and multiply it by 4. But if you remember that the area is equal to 1/2 diagonal 1 times diagonal 2, that just makes it a little bit easier. But to be completely honest with you, when I was doing this problem earlier, I just wasn't thinking, and I forgot that this was a thing. And I found the area of all 4, like a triangle, and I just multiplied it by 4. So either way works. Times multiplication. So how can we find the third side of this triangle? It's a right triangle. We have 2 of the 3.
Subtract 40 from 90. Or 180.
Would you add them and then subtract it from 90?
We're not.
They're the same?
I'm confused.
We're looking for the third side of a triangle.
Wouldn't it be 25 plus 20 and then equal to 180?
No, all of these are, y'all are all thinking angles and degrees. I'm just thinking, right?
Oh, that was it?
That was right. Yes. So if we have 2 out of 3 of the sides in a right triangle, like, yeah, if we had like 3 and 5, we would do 3 squared plus 5 squared equals c squared, right?
Oh, so you're using 25 and 20.
Yeah, that applies here. So we can say, let's call that x. We can say x squared plus 20 squared equals 25 squared. Y'all with me now? If you ever have 2 out of 3 sides of a right triangle, you can use the Pythagorean theorem. Subtract 400 from both sides. Okay, x squared equals 225. I'm pretty sure the square root of 225 is 15. Thank you. So this is equal to 15. What is this one equal to?
15.
Also 15. Wait till I finish this, okay? Just wait a second. Okay, so now I can use the area formula. Area is 1/2. What is one diagonal's length?
20.
Not just 20, it's the whole thing.
40.
40. So we got 20 and then 20 more, so 40. And the other diagonal is 30. What? Yes, 15 plus 15. You're right. So this is going to be
35.
0.5 times 40 times 30? It's 20 times 32. I think it's 600.
Yeah.